in 1850. So today, we're going to deep dive, pardon the pun, or don't pardon the pun, into what? In context for everybody, my peers on City Council and our esteemed members of the Planning Commission over here, and you members of the public. There's at least 3 entities, and there's really more, that define what we do and how we do it with water here in Ogden Valley. The Department of Water Quality, by regulation, states what can and can't be done in this Category 1 watershed that we have. This pristine water by state definition. This is pristine, perfect water. My words, not the state's words, and we're going to keep it that way. So the Division of Water Quality defines what can and can't be done with sewers, what can and can't be done with stormwaters, and things like that. And eventually, when we get everybody on Zoom, Nate Smith, who's our new city engineer, and I have been spending a lot of time lately on things related to sewers and to stormwaters. About a month ago, City Council met with people from the Weaver Basin Water Conservation District, and Scott Paxman and his group. And we learned from them about paperwork, water rights, who actually has the right to use what water. And we learned from them the perspective that Weaver Basin as a watershed is how that water is managed. And we have Ryan Broadbent here today from the State Engineer's Office who can answer questions about if we get to that. But the important point of that is we learned about paper water, the water right that many of us probably have living in the valley. But today we've invited Hugh Hurlow and his colleague Lucy Jordan to talk to us about wet water, the actual water, where it is, how much of it is there, how it's structured within the groundwater, how it's recharged within the groundwater, and the basis of that is their 29 report, groundwater in Ogden Valley, that was linked on the meeting announcement. Dr. Hugh Hurlow, sitting here in the front, is a hydrogeologist with 30 years of experience with the Utah Geological Survey and has managed the groundwater and wetlands program for the past 9 years. Hugh has worked on a wide range of projects that apply hydrogeology, water chemistry, and geophysics to help understand groundwater flow systems. Hugh earned degrees in geological sciences from Brown University, the University of Wyoming, and the University of Washington, and is a licensed professional geologist. I'm going to turn it over to you in a second, Hugh, but first I'm going to introduce Lucy Jordan. Hopefully, Lucy is on Zoom by now.
I sent her the meeting.
Okay,
She's getting there.
Lucy is the author, or the primary author, of the 2019 report, which was the basis of most of the discussion today. He is a hydrogeologist with 20 years of experience with the Utah Geological Survey. Lucy was the principal investigator of the Ogden Valley Hydrogeologic Study. You guys have a lot of syllables in the words you use. I'm just pointing out. Hydrogeologic study that we will be discussing today, and now serves as a manuscript editor in a part-time role. Lucy performed many intensive and detailed hydrogeologic studies while at Utah Geological Survey, involving groundwater basin, hydrogeology, water quality, and installation of groundwater monitoring wells. Before joining the survey, Lucy worked in hydrogeo as a consultant in mining-related groundwater contamination issues in the Salt Lake Valley. She has degrees from North Dakota State University and the University of Montana, and she too is a licensed professional geologist. So with that, I'm going to turn the presentation and the meeting over to Hugh, who will, you've got a presentation you're going to show us, right, Hugh?
Yes.
I'll let you introduce yourself to them if you want again, and take it over, sir.
Okay. Thank you. Right. So, I just crossed my 30-year anniversary at Utah Geological Survey, worked in a lot of different areas, doing a lot of different things.
Not including this study. I was not part of this study, but
the PI for the study, and is now not retired, but not in UGS. We contracted with it to do manuscript editing, and but I need Lucy always for guidance and a sense of security. So I asked him to join us, dropping in soon. So there it is. Very good. So yeah, another multi-syllabic, syllable rich title to the report, and it's a large report. It's a very comprehensive study. Oh, good, thank you. In fact, we now use it when we make our new employees read this as like a top example of one of these types of studies, and also to test their endurance, I suppose. Okay, so so the plan is for me to talk something like 20 minutes. So I can only cover the real basics. And in not huge detail, so I'll try to stick to the conclusions and not necessarily, go into all the details of how we derive things. But there's a whole bunch of slides afterwards, and Lucy's here, so if we need to know the more details, we can certainly go into that later. Okay, so let's just launch into it. And next, please. Is that okay to me just? Yeah.
I'm Ivana.
All right, so the project area is defined as the surface drainage of the three main streams and Wolf Creek, the four main streams that feed into Pine View Reservoir. And although we're called the Groundwater and Wetlands program at UGS, we know that in this case, there's a surface water provides most of the water to this area, and the surface and groundwater are very highly connected. So this really combined surface and groundwater study, and that's a theme that we've continued on in our more recent studies, and will continue, especially in these back valleys. So-called back valleys of the Wasatch, where you've got nice streams flowing through them, and there's groundwater, and the grid connection between the two is high. Okay. All right, let's go to next. So the study started with conclusions over the increasing population growth and water development, increasing, raising concerns over the potential impacts on the supply and the groundwater quality. And those, of course, continue today. We had all the right partners at the time involved, the county, the health district, the Water Conservancy District, Ogden City, BWQ, or the Division of Environmental Quality. And we've met and interacted with a lot of the local water providers and citizens, and we're very grateful for that cooperation they showed us in accommodating us and taking field measurements, things like, and sharing information. Most of the field data was collected 2015 through 2016, so it's been a while now, and it took a few more years because it was so complicated to actually finally publish. And then maybe some of you were at various presentations that Lucy gave. I believe there was one up here, and then there was definitely one down in Ogden. And then there was a smaller meeting, and then Water Rights held a larger basin-wide meeting. That might have been on, I don't remember if that was into 2020, but I know it was online. So this is kind of a recap of things, and Lucy went into much greater detail at that time. But again, I won't. And yeah, we actually won, or this report won a UGS award for the most influential and high quality report of the year, and is still a model for how we approach things. Look at the okay. And so I don't have time to touch on everything, but I am using the report from talking to Dawn and looking at the issues. I know that I just need to focus on groundwater, surface water. It's like I forgot to add, I'll have a very short section on water quality there. And then the overall water cycle, quantity of water flowing and moving through the system. Oh, so let's go ahead and do that. So first of all, Go ahead with the next one. So, groundwater is literally water in the ground, so it's below the ground surface. And it resides and flows through various geologic units, including sediments that are not consolidated. Sediments that are kind of semi-hard and cemented together, and bedrock. And so there's a lot of different properties of how the water is transmitted through those different aquifers. Both in terms of storage and flow rates. So that's really the first place we start here. In any of these studies. And so this is a schematic diagram of the valley and the drainage area. So this lighter colored area is the valley floor. And then below this line, this is meant to be a line along the land surface. And then this area, bottom of the diagram, would be like if we somehow could dig a trench, vertical trench, a couple thousand feet down into the land, get down and look at it and map out the distribution of the different geologic units below the surface. So that's just, some of you might be familiar with this already, but it's a geologic cross section. And this is pretty schematic and cartoony, but it's based on extensive study of the wells, what sediments the wells encountered at depth, and geophysics that we conducted for the project. One of the key things it shows is that near the mountain front, you have aquifer sediments that are predominantly coarse grained. And are, they vary with depth, right? But they all seem to be predominantly coarse grained sediments that transmit and flow around water relatively readily. Now, as you come downward in the valley and approach about where the reservoir is, the upper part of the reservoir, there's what we call a confining unit below the surface. That is a predominantly clay deposit up to 60 or 100 feet thick in places. That was deposited by ancient pond during Pleistocene time, when the lake was at its high stand and actually occupied this valley. So, of course, most of Lake Bonneville was out in Salt Lake Valley and all the way to the west, but there was a deep lake here. And so the sediments, the coarse sediments coming through the streams were trapped up against the mountain front. And then there was just fine grained sediments accumulated. So this is an important feature here. Confining, because below the reservoir, it separates the aquifer sediments into two units. One we call the shallow and confined aquifer. The other is the principal. Is confined, in other words, pressurized. So this point where confining unit wedges out and pinches out, and then you have less of a distinction with depth in the aquifer materials. That's a key point that we'll come back to. Okay, so let's go ahead. The thickness of that total aquifer system is quite a bit greater than originally thought in previous studies. It's up to 1,700, well, it's above 20,000, or excuse me, 2,000 feet. I think it's 2,300 feet. It's its maximum depth below town. So these colored lines just are lines showing connecting points of equal thickness of the basin of aquifer. So it's thickest right in the center of the valley, below the reservoir, below the, really, I guess, the eastern part of the reservoir, up to 2,000 feet. And then it becomes much thinner as you go out up the river streams. And then this dark line is kind of what is delineated zero thickness of the valley of the aquifer. So of course, as you go up along the streams, there are still aquifers. But they're kind of stream sediments. So this is the main valley for here. So the characteristics of storage and flow of groundwater through this aquifer system, and the thickness of it basically defines the total surface of groundwater. Okay, thanks. And So this is not maybe, basically, this just shows that we tried to map out the extent of the confining layer below the surface. Because it's, again, it controls a lot of the story of the groundwater. And you can see that, depth to top of confining unit are the units here. And so where it's not colored, basically the confining unit is at near these units, so there isn't a lot of cover, above it. And then it becomes progressively deeper outward and then thins out. Okay. Okay, so, groundwater levels. Basically, they visited, as many wells throughout the valley with a distribution, both geographically and with depth. As they could, and measured the water levels over a very short time period. Kind of map out how deep the water is in different places in the valley, and this is kind of a snapshot. Okay, so the typical way is to express it in terms of the elevation of the top of the water. And so it's highest up in the stream valleys. This is the 5,800 foot contour, and then it becomes progressively shallower for lower elevation toward the center of Pine View Reservoir. So water levels have the lowest elevation right at the Ogden city well. And so there's, you have to sort of look at this and think about the section. Water table with land surface, there's a depth to water map and is reported as well. But it basically shows, well, groundwater flows, gravitational potential from higher elevation. And so it all flows toward this Pine View Reservoir point. And groundwater pumping from the Ogden City well field, it's kind of focused that flow right to that particular wells. Okay, oh, sorry, and we also show groundwater levels up above the valley fill aquifer along those stream sediments that store around them. Those are the okay. You want me to change this?
Just one forward.
Yeah, I'll find you. Okay, yeah, right. Okay. Next other direction.
There we go. And do not let it councilman get.
Yeah, don't let them anywhere near.
Don't let me near the technology.
Anyway, these purple arrows just show the general, but I just kind of summarized general. Okay, next. There we go. So yeah, this is that depth to water gap in there that I mentioned. I won't go into a lot of detail, but we have an area, these kind of tan shaded areas are where the groundwater is very close to the land surface. And then it kind of becomes progressively deeper, you know, toward the ground. Over time, there's been a well here in Huntsville, evidently, that's been monitored by the US Geological Survey. The records go back to 1980 or so. So that provides a nice long-term record as for to the degree that well represents the whole valley of groundwater levels over time. So you can see there was a period, 10-year period, where there was a slight decline in the water levels. I should mention, so this x-axis is time, so increasing date to the right, and then depth to water here. So zero depth to water would mean that the groundwater is right at the land surface. So the groundwater is progressively deeper, going down this y-axis. So a downward slope over time on this means the groundwater levels are gradually decreasing. And so that seemed to occur from 1980 to 1990, but really you can't break out. I mean, we broke out 3 different time segments here, and calculated slope of those lines, and they're in the hundreds of the year they're all negative, but they're hundreds of per year, so effectively. We're not seeing at this level a decline in the ground level. That's not true everywhere. So go ahead and move to the next slide, please. So one thing we wanted to do was look back at the historical changes valley-wide. And to do this, we took measurements we made in 2016 and then went back to June 1985, where evidently the last kind of comprehensive sweep of groundwater levels was made in the valley, which compared those values. And throughout most of the valley, that reflects that relatively stable groundwater level trend that I showed, except in the Ogden well field, which shows up to more than 50 feet of groundwater level decline due to that pumping. And that's their, I think it's their only, or at least their primary culinary water supply. So there's a whole set of wells here. They're quite old. They were installed well before the reservoir was probably even bought, at least certainly before the reservoir was made. And at the time they were artesian. In other words, water would flow to the land surface through up through the wellbore. And I think quite strongly, in fact. Now the water levels are well below the land surface, and that's just a natural consequence of groundwater pumping. Sorry, that's probably. Let's get going on. All right. Okay. So that's the one area in the valley that we see pronouncing levels. And importantly, it's thought that basically that decline seems to be fairly continuous still. Now, if you set up groundwater pumping in the valley, eventually groundwater levels should and level out in terms of their downward trend. When they reach a new equilibrium, in terms of the amount of water they can capture and pull into the pumping. This has not occurred yet. So either they're pumping at a rate that can't be sustained, or they just haven't reached that equilibrium. And it would take some very complicated model to understand which is true. Okay, next. Okay, so here's the focus on surface water. This on the left is a hydrograph with a plot of the water levels in the South Fork of Ogden River over time. This is January 2016 through January of 2017. This is from a stream gauge that's maintained and operated by the U.S. Geological Survey. So you can see that water levels in the stream, and you all know this just from living here, right? They peak in kind of around April and May, and then begin to decline. This is actually not the water level, but the flow rate, excuse me. So you have minimal flow rate in January. It starts to peak up. It peaks high and during the peak snow melt time in April and May, and then gradually tails off. And this lower flow time, which here looks like it starts in late October, that's called base flow, right? You have no snow melt or precipitation coming into the stream. So basically reflects the discharge of groundwater into the stream. So you want to collect your stream flows at two different times, one when the water levels are on their way up in the spring, and one when it's at base flow. And we've color coded, this shows an example where we've color coded the stream reaches where we did the measurements, according to whether they're gaining or losing relative to groundwater. So along the blue stretches, if you measure at 2 points, the point downstream has a greater flow. And so that's inflow of groundwater into the stream. And then conversely with red, you see a decrease of stream flow between 2 points, which means water is flowing from the stream into the adjacent stream bed aquifers. Okay, so let's look at the results of that. Next slide, please. These sites, there are a lot of sites. And so that we deployed, I think it was at least 3 teams. You see, can remember, maybe it's 4. Running around all over the valley in a 2-day time period, so they would encompass the they would avoid into the stations in natural system that might throw these measurements off. Oh, did we skip?
Yeah.
It's all right. Okay, so this is March, this is spring. And if you can just kind of see, most of the lines are blue. We've got a red or a losing stretch along the north fork here, although it's a minor amount of loss within the area of the stream flow mechanisms. And we've got a significant loss on the south fork until it reaches the boundary of that confining layer, which is shown in the green shading, and then suddenly it's gated. So the upper parts, the east part of the valley, you're losing water from the stream to the groundwater. And once you separate the connection and just have a small amount of sediments above the confining layer, those sediments interact with the stream, and the groundwater in those sediments is higher, and so it tends to flow into the stream. So all of the streams gain when they reach the area where that confining unit is present. Okay, let's go to the next one. You probably won't remember, but basically in November, you see much more losing stretches on all the streams. Which means that the groundwater levels have declined over time. And so they're lower than this stream, which is stream water flows into the groundwater. But it's all connected system. So this means that up here, you're recharging the deeper aquifers. And further down, you're recharging the shallower aquifer from the stream. And then the canal loses 18 cubic feet per second from this entire region. Because that was in 2016. I don't know if they, I know there's the trend of lining canals and things like that to cut those losses. I don't know if they've done it yet. And so, from an operational standpoint, I think, well, that's not very efficient. This water becomes shallow primitive. And so it supports the wetlands, agriculture, and probably stream flow. So it's just part of the system, this canal loss. Okay, next slide, please. Okay, water quality is a whole realm, it's a whole thing, as my colleagues say. And so we did a sub-study on this water quality study, and I'm choosing not to go there now. You could review it if we wanted to pursue it after the talk. But the basic measure of water quality is total dissolved solids in the water. It's just how much elements are dissolved into the water. And that limits the ability potentially of water to be used, or limits the types of uses. Those are all clearly defined by the Division of Water Quality. And so in the end, water quality throughout the valley is excellent, as I mentioned, except maybe there's a couple wells that have higher TDS. I don't know why this one is so high. We'll see what I remember. But we did a process with BWQ called aquifer, aquifer water quality assessment, something with classification, where we measured the TDS throughout the valley and various elements of the chemical composition of the gas. And I believe it was classification. Stuff like slow. Okay, next. More concern is nitrate. And the reds show that you're in the trouble zone here. And so there are some wells that are in the 3 to 8 or 8 to 15 range concentration milligrams per liter of nitrated water. The standard is 10. So you don't want to be in that 8 to 10 or above range. You're risking water quality issues. Now, the great majority of these wells, they have this square shape, and they're in the shallow aquifer in the area of the reservoir. But the water that's being pumped and used, the groundwater that's being pumped and used, is below that confining layer. Right, so it doesn't show the same high nitrate levels. So that nitrate is sitting in the shallow aquifer above the confining layer. And it looks like there's a couple little areas of concern, here and there. Okay, let's just go through that. Let's just keep going. Thinking about time. Okay, so we used a lot of different techniques. Most of them pretty complicated chemistry and water balance type of approaches. To kind of try to quantify the amount of water that's moving through the system. This just shows a basic diagram of what the different inputs and outputs are. And so it's all relative to the valley fill aquifer and in the valley, right? So that's sort of a reference point here. So the inputs include, as I've mentioned exhaustively, recharge to the groundwater from the stream water, mainly as it flows across the eastern edge of the valley where the sediments are coarser and more permeable, and this confining layer does not exist, and so the water can potentially flow downward into the deeper confined aquifer. And that's the principal aspiration happen. So it's helped. Some of that water flows into the shallow sediments above the confined aquifer and exchanges with the groundwater, depending on exchanges with the surface water depending on the relative levels. There's also recharge to the bedrock in the mountain wall that flows slowly through the bedrock and probably even crosses fault zones along the edge of the valley and enters the main aquifer. Much longer and slower flow. That's actually thought to be quite a large component of the water budget in here. And eventually groundwater makes it back up to the reservoir. Also, as you know, there's a lot of precipitation relatively on valley floor here. And so that can just melt and percolate directly into the aquifer from the land surface. The withdrawals include evaporation and plant use. Withdrawal from the Ogden Valley wells, as well as the other smaller wells dispersed throughout the valley. And then there's outflow both in the surface water, of course, down the valley, and there's a minor amount of groundwater outflow down the canyon. So we had to quantify all this different processes in the study. So I'll just show the results. Next slide. Okay, so here's recharge. In other words, the amount of water in the different components going into the valley fill aquifer. The greatest component is in place recharge. So just the precipitation that melts and goes directly into the aquifer. The next is mountain block recharge, 17. So that's 24,000 in place recharge. Mountain block recharge is almost as much, over 17,000. So there seems to be quite a bit of connection the groundwater system from the mountain block into the valley fill. And then streams contribute about 13,000, and then a variety of other inputs, including canal seepage and unused irrigation seepage, and a little tiny bit from sediment. So the discharge, in other words, the loss of water, groundwater discharge to Pine View Reservoir is over 34,000 acre feet per year. So that's by a variety of processes that we've kind of outlined. A lot of it is from just subsurface discharge, but I think that also includes discharge of groundwater to streams that flows. Base flow to streams. So that's a discharge of groundwater to the streams during the winter time. And then the Ogden Valley well field pumps about almost 12,000, at least in 2016, it was 12,000 acre feet. So these two total quantities approximately matched, and that's reflected in the overall stable water levels throughout the valley. There might be some net storage change from the Ogden well field. going on. Over time. But this is like a snapshot for 2016. Okay. Except they used some different chemical signatures and the three main drainage areas to try to look at the relevant amounts of bedrock and snow melt that go into, or groundwater, excuse me, and snow melt that go into the streams. You quantify the value of the streams. Is there another? Well, let's hold on. So these are in thousands of acre feet, the inputs, 50, 52, and 63 from precipitation. And then this is sort of incomplete here. Is there another? It shows 33. I know it's 57,000 acre feet per year flowing from south toward Ogden.
Hey, you?
Yes.
Yeah, just keep, that's an animated slide, so if you just keep advancing, it should come in and you can see them.
Okay, thank you.
So you can talk about each stream as it.
Okay, so this shows the full results. So it's 125,000 acre feet per year of surface flow out. 57 on South Fork Ogden, 23,000 on Middle Fork, 33,000 on North Fork. And then the gold colors of the groundwater flow, subsurface flow, 7, 15, and 12. And what is 12? 12 is the Ogden City well field rounded up. So if you're starting to look at differences through the different subbasins, these are estimates of the basic groundwater and surface water. Thank you, Missy. I thought that was coming, but I didn't want to advance it. All right, cool. Yes, yes. Okay. Probably taking more than my time. So we'll just run through these. So we found that the basin aquifer, developed aquifer, that is the main by far of the aquifer valley. It's much thicker than we previously thought. And we mapped out the extent of that confinement there, which plays a key role in separating these groundwater from the upper and lower aquifers around the area of the Pine Reservoir. Looks like I've skipped it. Okay, so the groundwater system, surface water and groundwater are tightly connected to be considered basically one resource, especially on the east side of the valley. Different relative amounts of groundwater feed the streams. So the North Fork and Middle Fork see proportionately more of it flow from the valley versus just short, shorter time span snow melt and precipitation run. Whereas the South Fork receive more of its flow is derived from short-term snow melt and precipitation. And then quite a lot of groundwater goes into the Pine Reservoir. And then we have generally quite good water quality with nitrate concerns in the shallow aquifer in the area of the reservoir. If development continues using individual septic systems, that will just naturally gradually degrade the water quality in the aquifers. And so where that becomes potentially problematic is if there's pumping that pulls that water down into the main aquifer. And we think that's actually happening. I didn't show slides of that. We think that the Ogden Valley well field is starting to pull some of the shallower water, reservoir water down into the main aquifer because of the great difference in groundwater levels between the well there, the groundwater right around the well and the reservoir. So higher groundwater pumping really probably is not a great idea here because it would start to pull that upper water down that has less more water quality. Again, the water budget, you've got roughly 67,000 acre feet per year moving through the system. It's approximately a balance, except over long term, from that groundwater pumping below the reservoir. And, largest, let's see. just- Okay, yeah, and the valley fill aquifer mainly discharges to the reservoir. That's its biggest endpoint of discharge. Okay, I think that's it. Let's make sure. Oh, no, it's not. Okay, I'll just read through this. Lucy wanted to, blending cards, map out how things might change in the future as sort of the inevitable growth in water development occurred. So more use of water in the mountains may decrease spring flow in the mountains, right? So up out of the valley, decrease base flow to streams and the bedrock detention at the surface. So remember, groundwater contributes flow to those streams, so that will decrease the stream flow coming into the valley. Reducing canal leakage will lower valley fill aquifer water table. Like I already mentioned that. It's an important recharge component to the shallow valley fill aquifer. And then if the overall groundwater levels in the valley continue or decline, you'll see reduced base flow to the valley streams, as I noted, both within the valley and up in the mountains. There will be less discharge or groundwater flow to the Pine View Reservoir, so its overall water budget, just like the reservoir itself, will decline. And more shallow groundwater from the principal unconfined aquifer would recharge to the confined. So you might be starting to induce these downward gradients of flow from the surface aquifer, the shallow aquifer, into the deep aquifer. Shallow domestic wells would be more likely to exceed nitrogen standard. That would be more related to development with standard individual sediment systems. Okay, that's all, except for the last. Next slide. Just to thank you for being here. There's a lot more people here than I expected. I think the plan was just to talk to the council, but it's really, I think the amount of people here indicate the high level of concern and interest in the public, and I know Lucy found that too, right? Study. So we from our perspective, we love that. It makes us feel like we're getting good information across to everybody. I'm now the principal contact for this report. It's available online, which I guess will be in the minutes. There are some paper copies over there. I don't know if you all want to grab up most of those, but you can contact us. I hope there were one copy. So let's just say if you're here in the meeting and ask for a paper copy, I'll pay for it. But otherwise, there's a small charge for it. It's pretty now, but you can definitely download it as a PDF. So, okay. Okay, thank you.
Thank you.
Sorry, yeah. First of all, here's Lucy. Lucy, do you did I blow it? Do you want to add anything to what I covered initially before the question?
No, I think you covered the main points of our study. There's nitty-gritty detail and a lot more chemistry in the report if people are interested in that, but I know the volumes are really important. I guess I would say with the chemistry, an important point for people to understand is that the groundwater and surface water are really well connected in that valley. And so any contaminant sources that are visible at the surface or in your shallow aquifer, they can get into the streams and they can get into your reservoir and vice versa, can come out of the streams into the groundwater. So it's really important in Ogden Valley, particularly more so than other valleys in Utah, I believe, that relationship between groundwater and stream water is really intimate and should be thought of whenever people are thinking about putting in pollution sources, impacts from development. That's something to keep in mind, is to try to protect that shallow groundwater.
Thanks, Lucy. So before we open it up to the general audience, what I'd like to do is offer to my peers on council, if you have any questions of you. I do have some, but this meeting was for us and for our planning commission partners to really learn in a rather short time frame, at least the high level, what we're dealing with here. So I propose we do that first, and then if we have some time remaining, I think it's useful to see if the public has some questions. So let's go around. There we go.
Okay, beautiful, incredible science, and there's just awesome. I'm trying to convert it to a liberal arts major. So, and our dilemma, perhaps it's not a dilemma, as elected officials, mostly lay people, is we have two different major studies we are looking at. One is your study, by you, I mean, not you, but USG's, and the 2023 Bowens Collins study.
Right.
So Lucy, feel free to chime in. Have you all read that study? And what's your observation of the conclusions? Do you agree with it? Is it correct, valid, or invalid based on your own study?
Lucy, you probably haven't seen that, I'm guessing.
Okay.
Yeah, I think you did. What's being proposed is to move water from, as I understand it, the South Fork to the more of the North Fork. And
Right.
so the one observation I can make is that the dynamics between groundwater and surface water are a little different in those two areas. South Fork is dominated by the water in South Fork Creek is dominated by more short-term snowmelt and precipitation events, whereas the proportion of groundwater in North Fork and Middle Fork is higher. I don't know that I can on the top, just off the top. I was thinking about this a little bit today. But so you're changing water in the areas that have different kind of groundwater surface water relationships, given that it's close in both areas. And so they contribute different amounts of the two sub-basins contribute different amounts of surface flowing groundwater to the reservoir. So you might change the dynamics of that.
Okay.
And what would be you gotta think about that, the effects on downstream users. As Lucy emphasized, potential effects on water.
Okay.
That makes sense. Lucy, did you have anything you wanna? Yeah, I didn't.
I'm interested in how this all translates to what it means for us for new developments that come before us. That's where the rubber meets the road. And so as I read that study, their conclusions are groundwater development is highly constrained due to water rights closures and likely interference with existing wells. So you agree with that? And they generally cautioned against extensive further development. Do you agree with that?
I don't know if that might be the limit of where you're really.
Okay. So help me understand how your study relates to immediate developments that might come before us.
So one, in terms of, you would change the water budget numbers in the sub-basins.
What does that mean practically?
You would have less flow going from South Fork into Pine View Reservoir. you would have more consumptive use up in the areas that are being proposed to move the water.
Does that presume we'd be moving to do development, say up in well, the North Fork, the Old Creek, we'd have to move water from the south up to the north.
That's, I mean, that, as I recall, is the basic plan to take it out of Southport, pipe it up. Is that?
Okay, that helps. Let me think if I understand your study. It means basically we have abundant groundwater that is of high quality. And we do need to protect it from the proliferation of septic systems. Is that
Yes.
correct?
Yes,
Okay, so you're not in favor or advocating additional septic systems?
again, that's maybe beyond the limit of what I can say. However, there's a very detailed study in there, a chapter on water quality where there is a model where you can calculate the effects on water quality of different development scenarios. It's set up to do that for, individual septic system developments. It assumes the aquifer is well mixed in whatever, in terms of water in whatever area you're in, and it assumes a certain input and output. And associated water quality of the septic system.
Okay,
So it's not a lot by any means.
Sure.
It's for a whole area, but you do have a tool in there where you can evaluate different scenarios.
So to translate that for me, I was even a classics major, Latin, that is so far from my study. That suggests that, I think, if we look at development that is based on septics, we should be cautious and require additional study to ensure that doesn't contaminate the groundwater.
I think that's a very fair statement. What you can do with the model is decide, right, what's an acceptable level or amount of degradation of water quality, in this case, increase in nitrate.
So we should be skeptical of septics.
I mean, they would.
Right.
A little more nitrate into the groundwater, and 10 times larger sewer.
Okay, I have one more question. And it's a combined question. Does your study pose any conclusions about development in Ogden Valley and the amount of development that we could or should consider?
No, but again, part of that, the water quality modeling, you have different options in terms of lot size. In other words, density of individual septic systems within a development area that result in different levels of degradation of the water.
Okay,
So that is definitely meant as a tool for you to kind of evaluate those kind of questions.
is this tool meant to guide us in our decisions about additional development?
Yeah, because it's really up to you to decide what level of change in the water quality you find acceptable. And then you can kind of plan out, all right, what does that look like in terms of changes on the landscape?
Okay, now I have one more question. I'm so sorry. The study talks, and you all talk about water quality. Does it really address water quantity for new building?
It's not for new building, no.
Okay.
It shows the different quantities of water that are moving through the different subbasins. The basin as a whole and the different subbasins. When you get into quantity and how much you can pull out, then you start to impact downstream water users, and then Ryan. Right, is that fair? Yeah.
And is the Bowen Collins study more about water quantity and availability versus yours being about quality?
The Bowen Collins study is much more specific in terms of what do you think that, it's more about defining the potential and how do we serve that?
Okay,
I don't recall they discussed water quality,
I don't think they.
but that might have not
Yeah.
been objected or.
So. Stop me.
One, last one.
So, but these
Okay, we'll go
studies,
around the table. Right.
so these studies are different,
Yes.
don't address the same issue.
Yeah, I think they recognized our study though.
Okay, I got it.
So they didn't just dismiss it.
They're not like conflicting on the same proposition,
I would not
are
say
they?
so. They're looking at very different.
Okay, thanks.
So before we go on, I'll just say, so Utah Geological Survey is non-regulatory. That's why you saw me kind of hit some barriers there in terms of what I was willing to comment on. So our mission is centered around science that can be used to debate and decide, make these kind of decisions. So this is perfect for this study, because it's providing the information that now the town collectively can evaluate it and make its decisions. So I hope I didn't sound evasive, but I have, really clear guidelines as to where I really shouldn't go in terms of recommending maintenance or any kind of, yeah, I think that's fair.
Thank you.
Yeah,
Helpful.
thank you. These are great, thorough questions.
So can I summarize, have you summarized in your full opinion, or your opinion on the Bowens Collins study as far as the idea of taking the water to other areas of the valley? And then the overall effect of what could happen downstream of that, especially based off what the state's looking to do with water?
I didn't really think about, I didn't really parse out how that changing the place of that surface flow would affect the overall, system. I did note that I think we estimated 57,000 acre feet of flows at the South Fork into Pine View Reservoir. And the proposed eventual demand is something like 5,300, so that's about 10. So that, you would see that. You would, it's not trivial.
You'd feel it.
I think you'd notice a difference in terms of what's flowing through the rest of the stream down to the reservoir. Now, how much of that would come back to the reservoir anyway as return flow? I'm not sure. I think that depends on the efficiency of the use. I would have to guess that most of it would be consumptive use in its new location. So, no, how much, what relative proportion, roughly?
It depends on the uses, but irrigation, you're talking 60% depletion, and residential, it's down around the 20%.
Okay,
So a lot of it would probably come back to the reservoir.
by a lot, roughly half.
Yeah.
I think that's a good kind of rough guideline. Everyone a little more.
I have a very different type of question. So this was a study that was done, it started in 2015, results were presented in 2019. What is the stability of information moving forward? When do we need to do another study to make sure we're still on top of what's happening?
First thing I would do, and I have not done this, is look at that hydrograph of South Fork and evaluate whether you're getting less overall stream flow. So I assume, and some of you might know better than me, that the South Fork would be broadly representative of the whole system of stream flow into the valley. And Wolf Creek, I think, probably has some gauging. There's probably other gauges around the valley. That's what I would do. But is there less surface water?
So monitor the South Fork hydrograph, and if we see changes, then we need to come back and say, okay, we need another.
Potentially. Are those long-term changes? Are they short-term drought related? What happened in 2022, 23?
Okay.
Yeah.
Let's see.
Yeah, I think if you had anything. Well, I'm just wondering about your graph, those very small slivers for septic tanks. What does that mean?
Which there's
So you had a pie chart
Oh, yes,
Yeah,
that means the effluent out of septic tanks are a very small portion of the total groundwater system.
which means that they're adding to the groundwater
Yes,
in a very small
yes,
way, teeny tiny.
yes,
Okay, and in that groundwater are nitrates.
yes. Inevitably.
Is there another source for nitrates?
In general, there can be, Lucy, I don't think the background nitrate here is much at all.
So the background nitrate that we got with the study was 1.5 milligrams per liter in the principal aquifer.
1.5.
So somewhere around there, yeah. So that's relatively low. As you know, there's a lot of septic tanks, but a lot of those are on top of that the confining unit. And then there is agriculture around as a common source of nitrate, but there's not, big cornfields where they're pumping a lot of nitrate furnace fertilizer onto those fields. So those are kind of the two biggest sources that we see for nitrate in groundwater in Utah. So I think even in our study has a little bit of source of nitrate. There's a bit that talks about those, but it's by and large probably the septic tanks there. And I guess I would note that even though the septic tanks, many that are existing are overlying the confining unit and they would be inputting their nitrate into the shallow unconfined aquifer, that can eventually end up in the reservoir. And in our water balance, we found that there is some the water in the reservoir isn't completely cut off from the principal aquifer. There's some movement between those two, and it's interesting because it's a really thick confining unit, and in well logs it shows as a nice confining unit, but we found tritium in the Ogden City well field, and tritium you would not get if that's 10,000-year-old water that's making its way to those deep wells. So there's some intermixing of that shallow water and the principal aquifer.
Does that include soil disturbances from construction sites and roads?
No.
No.
Oh, the nitrate in the surface could, yes.
So when you say background, I think it was background nitrates, right? Is that what the word for it?
Yeah.
Is that the agricultural golf course, anything that's running off normally versus septic? So when you say background, it's that versus.
No, I think they
No.
no. Oh, go ahead, Lucy.
No, background is just that we took all of the data that we had and average it. So that's where you are right now.
Okay.
So it includes a wide number of wells that are fine, really low nitrate, but it also averages in a few wells that have higher.
Okay.
And that's what my question was for. You had a slide and I didn't quite understand. You had a lot at the mouth of the rivers, South Fork, North Fork, and you also had red wells, or red dots there. And they seem to be on the east side of the headwaters of the river. And that's shallower groundwater and it had high nitrates.
Okay.
Can you help me with?
Let's go to that slide if we can.
It had Pine View with red dots on the east side. No, keep going back, yeah, it was around pie charts. That's the same. That could have been, yes. I think there was another one also, but that helped me understand, yeah.
So that's in the 3 to 8 range. I can't speak specifically to those wells. The circle implies that they're in the main aquifer. Their locations varies. They're kind of in the area where the two aquifers are separated. Lucy, do you remember any?
Yeah. Yeah. So So on that graph there on the picture, where that light tan is the extent of the confining unit. So the wells, the dots that are squares, are above that confining unit. Those were wells that were put in by USU, and they did some sampling on it. So those are shallow wells in that shallow unconfined aquifer that has a lot of nitrate in it. You can see that's what they found, right? So that's where I'm saying that nitrate can eventually get into the reservoir because that's the groundwater flow path goes from that shallow aquifer into the reservoir. But that's what I was also just saying is there is some connection between that water and the principle too. So don't just look at it saying, oh, that's our shallow unconfined, we don't care about it. This is also a part of the system where groundwater and surface water is connected. So it is still something to be concerned about. The wells that are circles, so you see there's a couple circles that are red, three of them, right? Those are in the principal aquifer. And so those are, little hot spots for whatever reason. Maybe the well is near a septic tank. I don't know. We didn't look at those specific wells, but there's a couple spots where there are some higher nitrates in the principal aquifer. Overall, you see the yellow dots are most of the wells are really great. There's no nitrate in them. So you average all the circles, and that's where you get 1.5 milligrams per liter.
Thank you. Yes, my question was, is it interesting or do we know why they seem to be at the headwaters where the groundwater runoff would be coming in to the reservoir? Does that have any correlation or anything?
Probably not. I think what we found in past studies of this type is that these are more like related to the individual situation. We found high nitrate, like near where somebody feeds their horse and their well is not properly sealed with the surface. That kind of situation. I guess since you didn't necessarily investigate it well here, to sort of, but this looks to me like that individual landscape / well construction. Yes.
For the principal aquifer, I would say that, but for the shallow aquifer, almost all those wells have high nitrate, and there's a lot of septic tanks overlying that shallow aquifer. So that shallow aquifer has poor water quality throughout.
Okay. I'm good right now.
You have a following?
No, I think I can learn more from your own.
Well, hang on, because I'd like to.
Go ahead, Tom. All right.
Thank you.
Anytime.
This is not one that I wrote down, but I'm gonna bring it up. What are the historical nitrate levels in Pineview?
Did you record those?
Ooh, that could be. Are those recorded in this report? And what I'm looking for is that interaction between the groundwater, particularly this shallow aquifer and Pineview, and if you're able to show correlation.
In the reservoir?
In the reservoir. If we're positing that the groundwater, well, it's established that there's a relationship between the shallow aquifer and the reservoir, and the shallow aquifer has nitrate. What are we seeing for nitrates in the reservoir? Lucy, did you study that?
I don't recall looking at that in any detail. One thing to know is that the volume of stream flow that comes into the reservoir is large, right? So that does dilute the input from the shallow aquifer. I think there's quite a few studies on nutrient levels in the reservoir. So I think that data are out there, but I
Specifically
don't.
address it in this report. I don't recall seeing it. I know. Okay. Has the Ogden wells draw that groundwater that they're putting in the Ogden system, is it showing above baseline nitrates? Do we know?
Yeah, that's in one of the slides.
Was that an appendix? The septic tank?
No, septic tanks are in there, but
That's what I thought.
it's in towards the end of it.
I think there was like a hint of nitrate. That was one of some of the
Yeah.
Ogden wells, small, but there really shouldn't be any.
Well, it's,
And
and
so that was,
baseline is 1.5. Was it above or below? Do we know? Or statistically, was it near the same?
I'm trying to find it right now. I don't remember off the top of my head.
Ogden City Road.
One of our audience reports it's 1.46, so approximately baseline in the valley. So, thank you. You fielded some studies or questions about septic tanks. Our newer generation septic tanks, particularly those with active systems, are they protective of nitrates?
I'm not familiar right now.
Right, that's
I
not.
would expect so.
Right,
I would, and then you could probably, in that model, adjust the loading per tank. You know, if putting in based on the new.
first generation, I'll call them, not just a pit in the ground, but a system that has a tank of inshore leach field. Those nitrates are not removed biologically and eventually they end up in the ground. But the newer systems that are active with reverse osmosis and what have you, many of them are protective of and remove nitrates. I'm sure the audience wants to hear the answer to this question. You have a well that use a large number of cubic feet per second. What is the effect on that well if you put one at some distance, a new one within the same aquifer? Explain to my colleagues and the audience what actually happens underground, if you can.
So, yeah, each well, draws groundwater for it. And so if collectively, you're drawing enough groundwater, then everybody's water levels. It'll go down. That's excluding, some situation where you put a really large well really close to you. And run the well. And that's where it's not supposed to happen. That's where it gets into, beyond geology.
Right.
More of a linguistic type. Well, interference, which really isn't supposed to happen in a major way so that, the first well was unable to draw from.
Not supposed to happen, but it could happen under what circumstances?
I think you're breaching a legal topic.
Okay, we'll leave it at that. And I was not trying to box you into a legal point of view. Based on the study, what do you see as the highest risk, if I can use that term, for not enough water in the valley? And so if you picture the geography of the valley, you're sitting in the south side of it right now. The northern side is lower to the confined layer, lower to the principal aquifer. If all things are equal, what parts of the valley have the least available water without a bones and culinary pipe from down? And maybe the question is the wrong question to ask.
I would say the South Fork area it's the largest stream, the most recharge to the groundwater system. So the threats are groundwater development upstream from the valley to the extent that we capture groundwater that would otherwise flow to its streams. Expansion of the Ogden Valley, pumping, cone depression, and what's the third one? Oh, climate, long-term decline of stream flow. Was see anything? Did you add anything to that?
No, I would just, you could look at that, the one slide that had the animation on it that has the 3 different sub-basins. And we actually estimated numbers for stream flow and groundwater input in each one of those basins. So, if you take 10 acre feet out of one, then you need to think about and put it into a different one, then you need to think about what that can do to those areas. It's towards the end, the one slide that didn't have all the numbers on it. And so when you click through them, you get that one. So, your North Fork has 33.
Oh,
There you go.
there we go.
33,000 acre feet of stream flow coming from the North Fork River, through there, and not just into the reservoir, but this is the whole sub basin for the North Fork. And then there's 12,000 acre feet of groundwater. And then when you click through to the Middle Fork, you'll see, a little less surface water, about the same groundwater. And then you look at the South Fork, and it's a lot of stream flow, but less groundwater there. So whatever ways you want to move water around, if you're taking out of the stream in the South Fork, that may impact the groundwater that flows in there, but you have a less groundwater flow in that subbasin as well. So do wells be impacted in that area if you're not having that stream flow in there? Does that make sense?
Yes, yeah, thank you.
Any more questions from my colleagues?
Just a couple, you mentioned the development upstream, so are we talking about that whole watershed area? So anything that's developed up at Powder, for example, is gonna impact our flow coming down?
Yeah, kind of the dicey one, but potentially.
Which way it goes? I'm just talking water.
Potentially.
I just wanted to get my thing to see.
May I ask one more, Kay, before?
Sure.
And then it's the water flow.
Their fight.
Yes, you're quibbling over there. The water flow as it comes down, and then I'm thinking about the Great Salt Lake, which we need to protect in the next few years. It's really gonna be at a tipping point. We went to that water meeting in Ogden with the mayors and Fred, who was the gentleman from BYU?
Yeah, the professor.
Yeah, Ben Abbott, who was talking about saving the Great Salt Lake and what that's gonna take. How do we, is it monitoring, just still more monitoring, back to Janet's question? On the flow that we're releasing out of Pineview would?
Yeah. I would say that's a real key. Of course, you have to follow the water, if you're worried about things in lake, okay, kind of have to follow the water down.
All the way down. All the way, okay.
It's like they're aware of it, and that's a big deal.
Yeah.
This is a quick one, just, you mentioned 3 major threats to the groundwater in this area. One was the groundwater diversions upstream. The second one I didn't understand, expansion of the Ogden Valley cone of depression.
Oh, yeah. Yeah, the groundwater levels, around that Ogden Valley well, city wells.
Ogden City wells.
Sorry, yes, Ogden city wells, the water levels are gradually declining. I don't know if there's a continuous monitoring of that. But at the time of the study, it looked like that was continuing. And so the way aquifers work, the water levels next to the wells are lowest. And then the area of groundwater depression moves outward radially away from the wells over time. So that could eventually impact more things. It could induce more communication between the shallow and deep aquifers below the reservoir.
Now it's time for you guys. Oh,
Yeah,
For questions.
can we do planning commission next?
Yes.
And then
Yeah.
planning commission?
I'm gonna defer first to the members of our planning commission. And we've scheduled for about 10 more minutes. But I assume we can go longer. This is an important subject, so please start with you.
So I, like Councilwoman Ogden, have no experience with this and it kind of makes my mind spin. So I actually got a consult from a good friend of mine who I think you guys know, Lily Bosworth. And so I was just trying to get enough information to hopefully ask some mindful questions. So first of all, water quantity. So when we're talking about water quantity, one of the questions I have, you answered a bunch, and Janet kind of answered one, you asked one of my first questions. This study is fabulous, there's so much great information, and we really appreciate your explanation. And this study is between 7 and 11 years old, and a lot has changed. I moved to this valley shortly after this study was completed. And that's after that first Olympics in 2020, that's when we've seen the huge influx of growth going forward. How important might it be to try to update this study to get a current reflection of what the water, both quantity and quality, looks like?
I think the main thing, in addition to looking at, evaluating that, we'd be looking at the stream hydrographs, but also the water levels associated with the well.
Okay.
And the Huntsville well this month.
Right. Okay, also with regard to quantity, the discussions of piping water from South Fork over to the North Fork area to increase water. I've also heard rumors of a desire to pipe water coming out of Middle Fork. For example, Huntsville, since this study was done, pressurized their irrigation system, so it's much more efficient and does do things like that have impact on the groundwater, as well as the fact that Bill White just designated a substantial amount of water to go to the Great Salt Lake. That water, I have just learned last week, is going to go into what's called an exchange. Let's see, an exchange to deliver that water to the lake. And it means the water, the monastery's water will stay in Kazi and will not be released to come down to the reservoir, and then in the exchange, they're going to pick up other water right below Pineview to deliver to the lake. So that seems to be a potential amount of water that will stay in Kazi and not come down to replenish groundwater or stream runoff water. Do you know anything about that?
I don't, and I don't know if that's
Okay.
the case.
I'm sorry,
The way it's working.
it was announced last week.
His water's going into Pineview, the exchange is they'll then take it out of Willard Bay and put it into the Great Salt Lake.
Yeah, so the GSL commissioner last week said that that water will stay in Kazi. Anyway, so that would be a question to find out what is accurate, because, right, the Great Salt Lake, whether that water is getting to the lake, that's a whole nother question. I have one more question if that's
One
okay.
more there, then I'm gonna go to our other funding.
Yeah, with regard to water quality, it's my understanding that there are numerous other ways other than sewer, that as far as maintaining water quality, there's some other more natural ways and also some other man-made ways that we can maintain water quality, such as Councilman Hickman said, newer, more sophisticated systems for septic tanks, treatment wetlands, that improve stormwater runoff, retention and retention management as some ways to be able to, that are much more cost-effective ways to manage things and maintain a more natural environment. Is that okay? Thank you. Thank you.
Yeah, wetlands are an outstanding potential water quality maintenance mechanism if you can find the land and the water. And then they also improve the environment, the wildlife, a lot of people love to wander around. Boardwalks and trails in wetlands, so as manager of the groundwater and wetlands program, I'm heavily pro wetlands as a
Okay,
kind of more natural facing
thank you.
strategy. One of many, right? That you need.
Thank you for indulging my excitement about this.
Thank you for your questions. Other planning commissioners, one there, planning commissioner. Good.
It doesn't sound like you're doing any ongoing monitoring. Excuse me, of water quality or quantity, right?
Correct.
And seems that that would be very valuable, with respect to the valley and development decisions in the future, and also the Great Salt Lake and region right there. Who could we go to? And it'd also be valuable for an agency, I think, to do that.
The first place I would look, and I have to admit I didn't, was at what the USGS is doing. In terms of wells, I'm sure they still monitor that Huntsville. And I know they monitor the South Florida.
There's several of those, yes.
If anything, they've expanded or are about to expand their monitoring. So I would look at that first. As far as water quality, don't know if EWQ, I don't know, I would guess, just off the top of my head, that since it's not a problem area, there isn't intensive water quality one.
For those of you who haven't met Fred, he's on the planning commission and he's my right-hand man on the engineering side, is one of our volunteer engineers helping out the city develop its engineering and together.
Before we move on to Lisa Arbogast, you should introduce.
He did.
Oh, you did?
Yeah, he did.
All members of the planning commission, go
Yeah,
ahead and
let's-
raise your hands while you're here.
Let's introduce him.
Introduce yourselves, going around the table.
Erin Schaefer, I'm in District 2 and I am part of the Planning Commission.
Lisa Arbogast, I'm in District 4, Planning Commission.
Fred, you next.
Fred Blakely, District 3.
Terry.
Terry Xavier, District 5.
Guys,
Isaac Lloyd, District 5 as well.
thank you, guys. Terry, you had a question, right?
Yeah, one of your slides, you had some recommendations that came from your study, and one of them was you recommended larger than 6-acre lots to help alleviate this problem with septic systems. Could you clarify that?
That would have been the result of the modeling, based on kind of the parameters I described, assuming a certain amount of nitrate is coming out of the individual septic systems in the whatever area they modeled. I believe they modeled different sub areas in the valley. So basically that is assuming, I think the standard approach is to say 1 milligram per liter degradation of the ambient water quality. What is that? What is it? If that's the level of degradation you accept, what can you do on the development side? So that would be the average density, and of course, it's assuming, 6-acre lots, each with one distributed system. So you can get into all kinds of other engineering options there to focus it all in one place for all the treatment. That's a lot size based on those assumptions. Okay. So if you want the same degradation and you want to look at different options for wastewater, you could probably have a smaller lot size if you wish, if that were your choice.
That's all I got.
Thank you, Terry. Tyson, you had a question?
Yeah, so to be sustainable stewards of our water resource, is it safe to say we would want to keep our aquifer from being on a steady decline? Like it might go up and down. And in the study from the 80s, approximate dose study, it was generally going down. Is that accurate? Yes. So essentially, to be continuing to be stable as sustainable stewards, we need to be watching those well levels. And if those well levels are going down, if development or whatever is causing us to go down, that should raise the red flag. Is that right?
Sure, yeah.
And then the second part of being a sustainable steward is not lowering the aquifer, because what's going to happen is that higher aquifer already contaminated could be pulled down. And the last question is the Ogden City well the greatest liability currently to that, but that is pulling down deeper to that point, right? So it could be, that's currently the most liable place for high amounts of pulling from the higher aquifer to the low. And then as a planning commission / city council, what we can control is how many wells are put in, how many buildings allowed, we can do open wells. Yeah.
I'll follow up with that, though, give the Ogden City, well, is there any option of redoing it or changing it somehow so that that pull is lessened? I mean, you said that it's old, right?
I don't know, I mean, I assume they rely on a certain amount of acre feet coming out of that well field. So they would have to. Oh.
Use less water.
Yeah, I mean, just thinking out loud, if you if you distributed the wells more broadly, you would probably have overall the same volume. Individual water levels, we would be going down, so it would be a broader area of less water.
But would it lessen the degradation of the aquifer? Where you say that it's starting to pull it down, the potential of pulling down into that main aquifer, could that somehow be mitigated?
Maybe, so just assuming they're gonna pump what they need, the same amount, right? Right now, you've got a high drawdown in a small area, so there's a relatively smaller area in which you've got the potential for the incursion of the pulling down shallower, less good quality water. Right. Okay, now if you distribute that, well, then you broaden the area where there's a potential for that communication, but you decrease the driving force in any one place for that.
But even if it's coming from one place, once that degradation hits that main aquifer, it's hit that main aquifer.
I mean, as long as so let's just say you back off, pump it from that one, then the amount of, the rate of flow, the groundwater levels can respond pretty quickly, and the rate of flow into the lower aquifer would decrease. But it would increase, the potential for that flow would be over a broader area. Okay, all right.
Okay, to the general public. Lots of questions out there. I'm gonna start with,
Dawn, could they come forward?
yeah, I'm gonna ask you to come forward so that Al can pick you up. And we'll start with me. Everybody's gonna get a shot.
Tina Allred, from Eden. I'm also the president of the Eden Waterworks.
Tina, step back just a little bit.
Board.
You've lost it.
You've been decapitated.
Forward.
By the chairs.
Go back.
There we go.
All right. So I didn't read your whole study, but I read as much of it as I could and tried to absorb it. And it seemed to me like it specifically said in there, you weren't looking at other sources of nitrates. You kind of touched on septic in there. There was another study done about the same time, and I think you referenced it in this study from USU. And there was a PowerPoint presentation that was given to the county, which I emailed to all of the council members. And in that study, it said that 80% of the nitrates that end up in the lake were from surface water sources. So do you disagree with that?
I have not even read it. Lucy, did you have any? I don't remember any pushback against that. You had this
So they said what, 8% of the nitrates?
80% of the nitrates, and I think it was in the 90s of the phosphates that end up in Pine View Reservoir were from surface sources. They specifically mentioned, manure in fields and just natural nitrates that run off. And so I don't remember, I think it was on page 6 of that study, but that's what they presented to the county commissioners. And so I hear you talking about this I don't know the word, but where the water transfers fairly easily in the valley. And so I'm concerned that we're pointing at, you know, I'm not saying that septics aren't a source of nitrates, they obviously are. And what I hear you saying, by increasing the lot size, that is more land for the nitrates to be dissipated naturally. Is that in layman's terms?
Yes.
How that works? And so I'm just concerned that we're pointing at septics when it seems like, according to that study, we had a much bigger issue of nitrates. So I just wanted to point that out. You guys can look at that yourself, and I'll look for the study itself so that you can look for it. The other question I had was, you talk about the pipeline, and that we lose a lot of water from that pipeline, from the irrigation pipe, or the irrigation ditch. That comes, I believe it comes from Kazi. And so that leakage actually contributes to the groundwater. Yeah. And so I've heard, I think Weaver Basin was considering piping that. And so if that happens, that's also going to reduce the amount of water in the ground. It seemed like it was a pretty significant portion of that pie chart.
Yes.
So
It's in that area, I don't know where that water goes, be applied in the valley.
Right.
So maybe not all of it, but if it's applied to efficient agriculture,
and
you would have less groundwater recharge to the shallow lands.
Right, okay.
Near the south.
I just wanted to make sure that I understood that correctly. Thank you.
Sure.
Thank you too.
Thank you.
Jim, then Bart, then back row.
Jim Brown from here in the city. I have a recharge question. You have to excuse me, my eyes are still rolling. I read your report last night.
He means that, it's very compliment.
I got you.
But fires recharge goes. Can you tell us approximately how many additional households to be created would it take to have any adverse impact on the aquifer?
Not off the top, so really, we're looking at what's the increased water use from additional households. There's kind of a standard boilerplate number for water use per household. You know, the Division of Water Resources is working really hard to get us to reduce that. And so what would have a measurable, noticeable effect on the aquifer? I guess that's really the question.
Yeah.
Yeah, that's, standing up here, no, I can't. We'd have to decide what he could measure, what changes in groundwater levels could be measured, and then what would cause a serious problem? And how would that relate to, number of houses?
How would we go about getting the answer to that?
There's some kind of groundwater modeling, I don't know if there's a comprehensive model of a basin that shows the aquifers and then pumping, and that would be the way to do it.
Is there an expert is it feasible to find that out? Not necessarily by you, but is that something the city could contract out?
Yes.
To have a feasibility study on how many wells or whatever would have.
Probably, yeah, I think so. It would be complicated and probably expensive. But might have to do it there.
We're discovering that a lot of things are complicated and probably.
It's very expensive
Yeah,
too.
complicated and expensive, that's our line. Yeah.
Thank you. Mark Rager, 8051 East, 100 South. I have more comment from 5 years of observation than I do Western. I saw this, I heard about the survey 5 years ago. I saw the 2020 guy. And I bought the book. I read it. I heard about 6 acre lot. I read about 6 acre lots. I read about septic tanks. Even went to the point when this Sage subdivision, I live about a mile east of here on Spring Creek. I have 18 acres. I've got about 15 acres of grass hay. Spring Creek runs through my place. So when the Sage development came up after I read your book, I wrote this fine letter to the editor that says, many in Ogden Valley could soon be drinking from Huntsville towns with expanding cesspools. That's because I have a natural spring with an 1860 water right next to Sage. So Sage happened 3 acres. They ignored my suggestion for 6 acres. Before Sage, there were cows standing in the Spring Creek where Sage is at. Yes, they urinated, they defecated, they ate the cress. That probably helps clean the creek. Now Sage is there. They have a septic system. And I am seeing more fish in my creek. So what you alluded, so the agriculture, in my opinion, was worse than the development I've witnessed. Also, I fertilize with manure 15 acres of my grass hay. It's the cheapest way to do it. It's the way we do it. My grandpa owned the shit spreader. I own. My dad did. I did. So we're in a city that says let's protect agriculture, and let's screw development, but be thinking about what you're asking for, because what you gain, you might lose some.
You're in the back row. I don't know your name.
Nice to hear. Thank you for coming up and giving a presentation. And I tried to get Lucy here to come up and visit with us too on behalf of the Ogden Valley Watershed Action Group. But she's long gone. But I do want to say thank you.
Right there.
Hey, Lucy. And then also she has a presentation. You were unlimited to 20 minutes. She has a presentation on YouTube that goes for 15 minutes plus a Q&A.
Is that on YouTube?
And it is amazing. Just Google or search on YouTube Lucy Jordan Ogden Valley, and you'll find that.
There you go.
Like some of the other people in here, I've tried to read the report a number of times, but when you get to see her break it down, it's very digestible.
Yeah.
I feel like there might have been some sidestepping today. I'm not sure. But I wouldn't mind hearing more about the and maybe even from Lucy, but the 1 milligram per liter degradation that was used, maybe why is that something that we really should take for heart? Because this is a wonderful piece of information. I was also on top of the fires nitrogen study, and this is a big leap from where we were back then. If this is a legitimate recommendation to upzone to 5 to 6 acre lots, or use advanced treatment with their septic systems, or use cluster subdivisions and sewer, we need to be able to rely on those recommendations. So I want to see if that's a recommendation you have. We also have a lot of different reports, and Kay mentioned the Bowen Cons report, your report, and now we have the 9-element plan, which is more surface water related. But I want to drop this off. This kind of shows how those not necessarily overlap, but can be used together to answer some of the questions here. For example, you guys address degradation of groundwater. The 9-element plan addresses degradation of surface water. Septic systems is one of the primary threats identified in your study. Urban or just stormwater runoff is one of the primary contributors to degradation, highlighted by the 9-element plan. So just wanted to hand that off. And then get this down. I had some other questions. but I don't think they're that significant. Again, we have some volunteers here with the Ogden Valley Watershed Action Group. We've got Peggy, we've got Wayne, and we have Gina, and we meet twice a week. We would love to have people like yourself involved or to get your opinions.
Twice a month.
Twice a month.
Twice a month. Thank you.
Yeah.
Thank you, Liz. Okay, so do we have a question to answer? First.
Yeah. So,
And then you,
the way that modeling works is we provide a standardized scenario. If to achieve 1 milligram per liter degradation average in the aquifer with evenly distributed septic systems of the whatever nature of whatever effluent rate we specify, this would be the lot size. This would be the spatial distribution of those septic systems. So it does stop short of a recommendation in that way. It's a scenario. You can put in different, you can say, well, what if we go to half that? What would our nitrate degradation be? You can say, well, if we have nothing, you can look at the nitrate concentration there. So yeah, that's, and again, as a scientific agency without any bias as to the decisions that come out of this, it may well look like, I don't know, I don't feel like it looks like studying septic. It's just us staying in our lane and trying to provide a tool that you all can use to evaluate what's acceptable. Director Lucy, you want to add to that?
I'll just say that section of the report, there's a number of scenarios presented. One of the challenges we had in Ogden Valley was population per household. Because at the time we did the study, there's a lot of second homeowners that are empty a lot of the time. And so we used a lower people per household than we have used in other valleys, other areas of Utah. So like one scenario that we proposed was, okay, what if Ogden Valley isn't a bedroom community anymore? Maybe it has a more steady, live there all year population. If we just filled up all the houses that are already built, what does that do to groundwater quality? And then grow from there. So there's a number of different scenarios that we did. It is a sort of a gross estimation because, like Hugh had said, it's taking the water that's available for mixing in the aquifer from, the whole rest of the study that we did, figured out how much water's there. And then it takes per septic tank, you have, an amount that comes out of that septic tank, and you have a concentration of nitrate, which is also just a proxy for everything else that's in the septic tanks, right? It's not just nitrate. Nitrate's not actually all that damaging. It's the unused drugs that are in your wastewater. It's the phosphate that's in your wastewater. It's a number of things. So it mixes all those and assumes everything's mixed. Now, in this scenario, I think we took the top maybe 200 feet of aquifer. So you're taking that volume of water and mixing in your septic tank that's coming in at the top. So that's why you see, the whole aquifer doesn't have one number. It has higher and lower spots. And as was pointed out, this is just the septic tanks. So there's other surface water sources, other sources of contamination. So it's just a tool, and there's many different ways you can look at that. We didn't consider advanced systems that treat the water quality more. We didn't consider any areas that were already sewered. We left that out, so they're not contributing to anything. We didn't consider maybe areas that were maybe going to be sewered soon. We just said, here's how many are there, and if you continue with that scenario, depending on how many people you put in them, then this is the amount of area you need per septic tank, which is what we converted to lot sizes to be at that level of nitrate. So at whichever level you want. We said 1, that's kind of what we've typically done in different areas. Say, okay, so here's 1, so then you can kind of extrapolate that out. Okay, let's say we're okay to have 2 more milligrams nitrate per liter in our water. So you can kind of extrapolate that out. But 1 is just a number to use in the model. So that is completely up to the communities to decide how do you want to protect your groundwater. And that's only from the septic tanks. So any other sources you have are going to be in addition to that.
Question from Trina White, and then, are you able to stay after?
I need to talk to you about that.
I'm not gonna commit to his time.
There's supposed to be somebody at 4 o'clock in the office, but I don't know if he's coming in.
So,
Put it that way.
we're a half hour past our scheduled end. So Trina White's gonna ask a question, and if there are no more, I'm gonna bring it back over to the council and we'll close up, but I'm sure this is not the last time we'll talk about water.
Is this Ogden City well one of the main sources of water for Ogden City?
I believe so.
Yeah. 2017 till now, the amount of people in Ogden City and assumed use of water in Ogden City is dramatically higher, so that pull down of that well will be dramatically more.
No, I don't know. They'll have a certain amount they're allowed.
Okay.
And whether they're at the maximum and could increase or not, they don't know the answer.
And in that same amount of time frame, 10 years is a fair amount of time. If you just visually look around at what's changed here, as well as statistically looked around at what's changed here, we have lost quite a bit of farm ground because we've gained a lot of development. Some of that development is on septic, some is not. But the way the developers are developing from 2017 to 2024 is dramatically different in their practices, which can help with the stormwater runoff and the quality of the water too. They said that 2022 is our lowest water year, but 2023 was our highest water year. So it'd be very interesting to get accurate information and measurements of these chemicals that are going to affect this, if there's a way. So I don't know if we can get help from the Division of Natural Resources, Water Resources, whoever, to get some current information.
Kind of a refresh or where are we now?
Yeah. Right. Our settlement hasn't gone up, has it gone down?
Sorry.
Thanks, Trina.
Okay, I'd like to, do you mind, Don? Miranda Menzies,
Last one.
I understand I'm the last one. And
So they all go.
where am I now?
There you go. Perfect.
I'd just like to thank Lucy and I'd like to thank you. Everybody been waving, that's what a well-read document looks like after 6 years, 7 years. The number is actually 1.43 in Ogden City wells.
Miranda, step back.
You're
just at the table.
Behind the table. Yeah, thank you.
It's 1.43, not 1.46. And I do feel that we have to address this nitrate thing, but I think we should all recognize that it's a slow process. We're not talking about immediate disaster. This is a long-term issue that we need to address. I'd also like to say, I think the whole question is whether nitrate is conservative. That is to say, whether it degrades to any extent. It doesn't really degrade in groundwater, is my understanding, but if it's going from groundwater into surface water and back again like this, I think you can have some changes. And that's one of the things that would need to be looked at, whether in fact there is some nitrate destruction within the natural system. I'd also like to address this 1 milligram per liter thing. I have been told directly by people at the Division of Water Quality, which is an enforcement agency, that they use that as a criteria. That is to say The fact that we're starting from close to 0 and getting to 1, they regard somewhat similarly to going from 1 to 2. Is that what you've heard also, Hugh, or not?
I don't know. So if that's what they told you.
I think this is a question that council needs to address.
Yeah.
And I'd also like to say those USU wells, they are not supply wells, they are monitoring wells. And so you can have a far higher number in those monitoring wells, and it doesn't mean diddly squat, because you don't know if the water's actually going anywhere. What really matters is what's in our municipal wells, what's in our private wells. I'd like to advocate for a free testing service, which I believe could be relatively easily arranged so that people who have private wells can find out what their water quality is. It's just a suggestion. Thank you.
Can I just say testing is available? We were based in water, I do it twice a year. Just
Congratulations.
yes,
Glad you did that.
we were based in water. It's not very much
You know
money.
what your numbers are. That's
Yes, I do it twice a year.
excellent.
Thank you, everyone. Thank you, Hugh. I'm gonna bring it back up to council, and I'm gonna hand the gavel, so to speak, back over to the mayor to close it the room. Up to Hugh whether or not he can stay and answer questions, but as I'm sure you heard me moments ago, this will not be the last time we talk about water, I'm sure, here within the Valley and City case. Mayor.
Just one last round of, any other comment or discussion from the council? If not,
Thank you very much for your time and
yes.
this research that you brought us.
Thank you both, yes, to our guest experts, as well as everybody in the audience that has come out in the middle of the day. We appreciate that as well. So thank you, and thank you, Don, for putting this all together. Yes, I will take a motion to adjourn.
Oh, wait, what? Where will this be able to be used to the Zoom link didn't work?
It's on YouTube. It will be on YouTube.
We have a motion to adjourn. Is there a second? Yes, seconded, motion and second. All in favor, say aye. Motion, we are adjourned.
Sorry.